Okay, so having done all this work, we can finally figure out how our properties are going to change after a shock wave. So how's the density change, pressure change, temperature change, Mach number change? Now, the way we do that is we take all of our continuity equations, as well as one relation which I didn't really go into very much, which just shows how our characteristic Mach number is related to our Mach number. And with that, we can then say, okay, we can figure out how pressure, density, temperature, and Mach number change afterwards. We have 4 equations, and we have 4 things we're trying to find after the shock waves. It works out fine. I'm not going to go through that full derivation. Okay, the derivation can be found in your textbook. It's there for you. And here's the equations. If you want to write them down, you're more than welcome to. What I want to say is this. These are tabulated. There's an appendix, Appendix B. Once again, I'm going to go ahead and show you that appendix in just a minute. And so don't use these, don't plug them into your calculator unless you have built like an Excel spreadsheet or a code to do it for you. Because if you try to type these into your calculator, odds are you're going to make a mistake somewhere when you're doing that, and it's going to throw your numbers off in your problems. You're going to get them wrong. So either make a calculator to do it for you, so you can just type in a Mach number and everything pops out. That's great, that's fantastic. Or just look them up in the tables. Now, what we can see for all these things is that pressure, temperature, and density, they all increase as the shock wave gets stronger and stronger, or where we're putting that, that's my Mach number before the shock wave gets higher and higher. The second thing you see is that that ratio of stagnation pressures drops dramatically, and that's not a good thing. And also my Mach number drops dramatically as I have a stronger and stronger initial Mach number, okay? So pressure, temperature, density, they go up. That ratio of stagnation pressures goes down, as well as my Mach number, it goes down. But now let's go ahead and see where you can find this in the textbook. Okay, so here we are. Here's your textbook. This is Appendix A. This is the wrong one. If you hear normal shock, you need to go to the normal shock tables, which I'm going to show you how to jump to. I had the back arrow, so I'm now in chapter 20. I had the forward arrow. I'm back in, it betrayed me. Well, I'll just choose it. Appendix B, here we go. Perfect. And so now I'm in the normal shock properties table. So I have Mach number on the left. Once again, this is times 10 to the first. So this is not 0.1. This is Mach number of 1. And it goes up from there. You're like, why don't you have anything below 1? Because then I wouldn't have a shock wave. Simple as that. And you have a lot of different ratios here. This right here is the Mach number after the shock wave. You've got pressure, density, temperature. Only bad thing is when you're scrolling down, it gets kind of hard to figure out which one you're supposed to be in. But just do it one at a time, you'll be fine. And if you don't like interpolation, which you'll have to do occasionally, I strongly suggest you take some time and build a calculator in an Excel sheet or in a MATLAB file or in Python or something. It's not that hard to do. It's an equation that so long as you test it, you can get it right pretty easily. Just if you're trying to type into your calculator with a bunch of numbers, it always goes wrong eventually. Okay, so here's Appendix B. This is normal shock properties table. Use it, abuse it. Just make it a lot easier on yourself by avoiding a whole bunch of calculations when you can just look up the numbers. Thank you so much. I'll see you all next time. Bye-bye.